basic continuous time signals. The unit step function u of t, also known as the Heaviside unit function, is defined as u of t equal to 1. Condition is t is greater than 0. If 0, condition is t is less than 0. Which is shown in figure 1.4a. Note that it is discontinuous at t equal to 0, and that the value at t equal to 0 is undefined. Similarly, the shift unit step function e of t minus t0 is defined as e of t minus t0 equal to 1, t is greater than t0, 0, t is less than t0, is shown in figure. Here unit step function, a is unit step function, b is shifted unit function. Here unit step function e of t, 1. Condition if t is greater than 0. T is greater than 0. If t is less than 0, here t is total e of t, here this condition. If 0, e of t is 0 here, because t is less than 0, which is in the shown the figure A. Note that it is discontinuous at t equal to 0. Here discontinuities. Okay, here discontinuities, and that the value at t equal to 0 is undefined. Here we can't able to say value. That's why here they told undefined. Similarly, the shifted unit step function e of t minus t naught. Similarly, the shifted unit step function e of t minus t naught is defined as e of t naught, e of t minus t naught equal to 1. Condition is t is greater than t naught. When 0, condition is t is less than t naught. We'll see here e of t naught here 1, this one, condition t is greater than t naught. T, this is the t is greater than t naught. This is the t naught. Okay, so here t is uh, that is t is greater than t naught. It means here t naught is greater than t is greater than t naught. Here condition u of t minus t naught equal to 1. Condition t is greater than t naught. Here is the t naught. Okay, so when t is greater than t naught, it means this area full greater than t naught, this area full less than t naught. That is this condition. Second condition here, first condition here t is greater than t naught, here t is less than t naught. That's why here always 1, this value. Here always this is the scale 0 here. t is 0, t equal to 0 here. Here this scale, here 1, here 2, t is 0, this scale u of t minus t naught also here 0, here 1, here 2 approximately, okay, and so on. Here t is 0, t here approximately equal to 1, 2, 3 and so on. So t is greater than t naught. So here in this condition t is greater than t naught, this area full. That's why here this area full t is greater than t naught. Okay, here t naught 0 only. Okay, so that's why here t here that's why here full always v of t minus t naught equal to 1, because here this is here 2 u of t minus t naught, here 0, here both are 0, t also 0, u of t minus t also 0. So here 0 when t is less than t naught, here the here full area t is less than t naught. That's why u of t naught here 0. Okay, this area full 0. Here also u of t minus t naught 0, here up to here. Okay, that's why shifted unit step function. Shifted unit step function that is from here to here shifted. Okay, here to there shifted, here that's this much, from here shifted this much distance shifted. Okay, unit step impulse function. The unit impulse function del of t is also known as the Dirac delta function. Dirac delta function plays a central role in the system analysis. This is the main unity impulse function. Traditionally, del of t is often defined as the limit of a suitably chosen conventional function having unity area over an infinitesimal time interval as shown in figure. Here the 1.5. Here here unit impulse function del of t is also known as Dirac delta function, plays a central role in the system analysis. Traditionally, del of t is often defined as the limit of suitably chosen conventional function having unit area over the infinitesimal time interval as shown in a figure, and possess the following properties. This is as t. Okay, in this between area epsilon, here epsilon 0, here 1 by epsilon. Okay, here del of t equal to 0 when t is not equal to 0, when infinity t condition is t equal to 0. You see here t is not equal to 0, t is not equal to 0 means here only t0, here only t0, remaining part full here not 0, t not 0. When where t is not equal to 0, their impulse response, impulse function, unit impulse function, del of t is 0. Yes, careful 0, careful 0. Where t equal to 0, here only, this area only. There del of t equal to infinity. This is the point. Here. Del of t is, this is the del of t. Here. It means here, when t equal to 0, that time del of t is infinity. When t is not equal to 0, remaining this of 0, yeah, left or right, del of t is 0. That is integral over minus epsilon to minus epsilon to 3 epsilon plus epsilon del of t dt equal to 1. It means here epsilon here this much area epsilon, okay, this much area. Here epsilon 0, here 1 by epsilon, 1 by epsilon, 1 by epsilon, okay. From minus infinity to plus minus epsilon to plus epsilon, okay. Del of t dt equal to 1. Yeah, this is point, okay. But an ordinary function which is everywhere 0 except at a single point must have the integral 0. The Riemann integral sense, thus del of t cannot be an ordinary function, and mathematically it is defined by minus infinity to plus infinity integral over del of t pi of t del of t dt equal to pi of 0, where pi of t is any regular function continuous at t equal to 0. Ordinary function which is everywhere 0, everywhere 0, yeah, except a single point here only, except a single point. First you have the integral 0, Riemann integral sense. Thus del of t cannot be ordinary function. Yes, del of t is not a ordinary function, and mathematically it is defined by minus infinity to plus infinity pi of t del of t, here the del of t equal to pi of 0. Pi of t is any regular function continuously t equal to 0. Pi of t equal to, when t equal to 0, at t equal to 0, pi of t is any regular function. Here pi of t also any regular function. An alternative definition of pi of t is defined by integral over a to b pi of t del of t dt equal to pi of 0 when a to b, that is a is less than 0, 0 is less than b. When if you get a 0, then condition is a is in b between a and 0, that is a is less than 0, b is less than 0, or 0 is less than a is less than b. Undefined means a equal to 0, b equal to 0. Here in between a and b, pi of t del of t dt equal to pi of is 0, condition is a is here, a is less than 0, 0 is less than b. In this condition pi of 0 result. If we multiply